Good evening, grade 12 learners. Igama Umuzi Mthembu, ithuta yenu ye-geography. So today we are going to be doing climate and weather as one of the topic. Bese mabeqala nje bekufundisa maqala unyaka beqale ngayo. So today we are going to be looking at the mid-latitude cyclones. Mid-latitude cyclones, under it we are going to be looking at some characteristics akhona. So these are the characteristics of a mid-latitude cyclone. We have amanye amagama, alternative names like temperate cyclones, extratropical cyclones, frontal depression, or wave cyclones. So if you see any one of these names with exam paper, you must just relax. Wonke la magama asho ukuthi it's a mid-latitude cyclone. What exactly are mid-latitude cyclones? These are low-pressure weather systems that occur in the mid-latitude cyclones or mid-latitude of the Earth, usually between 30 degrees as well as 60 degrees, both north and south of the equator. So this system is made up of a cold front and a warm front. So the cold fronts reach and affect South Africa mostly in winter when the high pressure belts are in their northerly directions. And then another characteristic of a mid-latitude cyclone, cold fronts affects South Africa in winter, bringing rainfall. So the areas that we are focusing or that mid-latitude cyclone is affecting in South Africa is the Western Cape. Western Cape receives rainfall during the winter season. So the warm front is bent southwards away from South Africa and does not affect the South Africa. Three or more, if there is three or more of a mid-latitude cyclone, we call them, or they are known as, families of cyclones. And also, a mid-latitude cyclone moves from west to east, driven by the westerly winds. So these are your mid-latitude cyclones characteristics that you need to know. Let us move on. Looking at their area of developments according to the weather. So here, ngifakele file map lana, which is a synoptic weather map. File a condition of summer, file a condition of winter. So let's start off by looking at the summer synoptic weather map pattern. Remember, summer in South Africa, we can, singasho ukuthi iqala mhlambe ngo December kanje yabo to mhlambe March kanje, something like that. Okay, now let's just look ukuthi ngesummer kwenzakalani. Ngesummer in the interior there is a low pressure system that is dominating, and you can see right there ukuthi we have an intertropical convergence zone that is dominating. So the intertropical convergence zone is actually migrating with the apparent movement of the sun. So wherever a intertropical convergence zone is, you must know ukuthi nje ihambisana nokushisa. So if you look carefully la on my left and on my right, I have two anticyclone. They have moved downwards. And then also if you look here, I have a cold front that has moved further south, ilapha ezantsi. So ichaza ukuthini konke lokho? Ichaza ukuthi this is summer season ngoba we can't see Kalahari high pressure. Kalahari high pressure has moved up phezulu, and these two here anticyclones have moved southwards. Let's just look at a winter synoptic weather map. A winter, obviously it's happening in June here in Southern Hemisphere. And you can see manje ama anticyclones ami ukuthi they are aligned. So they are in one line. So this one here in summer, remember it was up there, phezulu. So it has shifted now down below to the bottom, and yahlala nje lawo interior of the country. And these two, A and B, have actually moved up. So they have shifted upwards, northerly direction. So they are in one line now. And if you look carefully, cold front has now reached the country. and it's affecting areas like Cape Town, areas like Port Elizabeth. So that is an evidence to show that this is a winter synoptic weather map. Okay, now let's just further go on and look at the conditions for the formation of a mid-latitude cyclone. It forms at the polar front. Okay, so warm moist air from the subtropical high pressure meets with the cold fronts, or sorry, not with the cold front, but with the cold dry air from the polar high pressure at the polar front. Remember, grade 12, these two parcels of air, they meet, but they do not mix. So these MSs blow past each other in opposite direction. A disturbance along the polar front causes unstable air, resulting in a low pressure. So this results in the circulation of air. Okay, now let us look further and look at the well pressure belts, still looking at the conditions for the formation of a mid-latitude cyclone. Remember, grade 12 in determine a mid-latitude cyclone, it occurs between 30 degrees as well as 60 degrees, both north and south. So which means a mid-latitude cyclone in the southern hemisphere, it takes place, so it's occurring right here. And then in the northern hemisphere, it's occurring right there because there is 30 degrees as well as 60 degrees. Now, you have two parcels of air that are blowing in opposite direction. The other one is blowing to the left, to the right. Then the other one is blowing to the right. Remember, these are cold air, these are warm air. So both of them, they are blowing in opposite direction. So basically, so what you need for a mid-latitude cyclone, you need what you call a frictional drag. So a frictional drag is whereby one air is pulling to the opposite direction, and then the other one is pulling on the opposite direction as well. Okay, let's just look. It's another conditions for a formation of a mid-latitude cyclone. So let's just look around here. This is the equator. So air rises here, atmospheric pressure is low, climate is wet, okay, rainfall focus. But in our area of focus is around here, 30 degrees, between 30 degrees as well as 60 degrees. So let's just look at 30 degrees, which is air falls, atmospheric pressure is high, climate is dry. And then the most common situations that occurs right here are desert. So, and then again, along at 60 degrees here, we have air rises up, atmospheric pressure is low, and when the atmospheric pressure is low, there's a possibility that the climate there will be wet. So we'll be having a cloud formation that will be taking place or occurring. Okay, let's just look at the mid-latitude stages, mid-latitude cyclone stages. We have 4 stages. The first one is initial, the second one is development stage, the third one is matured stage, and then the last one is occluded stage. So the most important stages in your exam grade 12 are the matured stage as well as the occluded stage. So let's just look at the initial stage when a mid-latitude cyclone is developing. So you have, remember, let's say this is 60 degrees, according to the world pressure belt. So you have the 2 parcels of air that are meeting, but they do not mix. If you look carefully here, we have a hectopascals are 1008, and then hectopascals are 1006. And then again, same thing now at the bottom. What does that tell us? It tells us hectopascals, or the pressure is decreasing as you go towards the center, which symbolizes yes, there is a low pressure system taking place. There is a frictional drag as well. So warm air is pulling to the right, and then cold air is pulling to the left, which tells us there's a frictional drag. To stage number 2, which is development stage, you can see since the warm air is lighter than the cold air, so what will happen is cold air, since it has the greater speed, it will try and overtake the warm air. And you can see with the wave, there's a wave formation, or the wave it's developing, starting to development within this stage here. Let us look at the most important stage, which is the matured stage. You can see the wave is actually formatted here, and then you can see the movement of air. It's moving on a clockwise direction. And then cold front is chasing after a warm front. And then if you can see here, Patnendao, this area here is called the warm sector, but below here is called the cold sector. And the reason why we say it's a cold sector is because you have a parcel of air chasing, you have a parcel of air chasing. Now there's a cold front there with a steep pressure gradient. The reason why we say it's a steep pressure gradient is because our isobars are close together. So that is where the greatest movement of speed is. And then now we have a jointed slope along the warm front. Okay, let's just look at the occluded stage. So this is a dissipating part of the mid-latitude cyclone. Oh, I forgot to mention what type of rain do we have here, but I'll mention it at a later stage. But just for now, we are experiencing a heavy rainfall, hailstorm, thunderstorms, even strong winds. Okay, let's just look at the occluded stage. Occluded stage and say mid-latitude cyclone, and you can see the cold front is now catching up with the warm front at the apex. So if you look carefully right here, kugcina symbol here warm front, so which means this is a warm occluded stage, and then we have a cold occluded stage as well. Okay, let's move further along grade 12. So you can see the side view of a mid-latitude cyclone. Okay, what I was explaining earlier on to you at Kaleni. Yes, we have the fully developed system, which is a matured stage, and then we have a warm front right there with warm conditions. So in the middle, we have grade 12 are the conditions that are going along with each one of the fronts, which is the warm front as well as the cold front. So if you look, Lessons, there is a development. Grade 12, whatever I have right here is representing the top part. So I still have a cold front, but the thing is now I've just included types of clouds that are dominating the cold fronts or along the cold front. So the type of clouds that I have here are cumulonimbus clouds. So I want to develop along the cold fronts here. And then the types of clouds that will be found along the warm fronts are nimbostratus, altostratus, as well as cirrus clouds. So these cirrus clouds, they bring like light rainfall, but cumulonimbus clouds, they bring heavy rainfalls. Okay, they bring showers. Remember, there's a warm sector right here. So conditions within the warm sector are warm. Okay, let us look now. Ngalaga right weight and sana for the cross section of a mid-latitude cyclone, looking at the cloud types here. So for your exam grade 12, as you are preparing, if a cold front passes the area, what type of conditions will be left behind? That is the most important thing. So the types of conditions type of condition that will be left behind once the cold front is passed are the cold conditions. Heavy rainfall that will be left behind. The pressure will increase because it's cold. And then once again, warm front, types of conditions that will be left behind as soon as the warm front passes. You will have warm conditions that will be left behind, as well as light rainfall will occur. I mean, warm fronts, good people, you must know, it doesn't consist much of a rain. It's unlike the cold fronts. So cold fronts here, as you can see, cold fronts pressure gradient, its cold front is steep, resulting in a rapid upliftment of warm air. If there's an upliftment of warm air, temperature will decrease, pressure decreases, but increases with cold sector, humidity decreases, cloud cover increases. What type of clouds are we going to find right there? Cumulonimbus clouds. Chances of precipitation increases, So we are expecting to have heavy rainfall, even snow as well is possible. So due to veering and backing winds direction, the direction changes. So we call this veering, the veering of warm air, advection, anti-clockwise circulation in the southern hemisphere, backing cold air advection, as well as clockwise circulation in the southern hemisphere. Okay, it's the opposites. The opposite lay phezulu the northern hemisphere. It's the opposites in the northern hemisphere. So right here in the warm sector, there's a warm sector there. Okay, what happens here? There's a decrease in wind speed. Warm conditions are prevailing. Remember, when I've said when the warm front passes, what conditions are going to be left behind? So in this area as well, there will be calmer conditions, possibility of drizzle or no rainfall. You know, there's a higher humidity because but when the cold front is approaching, it's a different case. It's a different case. Remember, the cold front is after the cumulonimbus clouds. This brings more rainfall. And then again, the warm front, pressure gradient at warm front is gentle. And air rises along this front. Temperature increases, pressure decreases, humidity increases, cloud cover, which are nimbus stratas. Type of precipitation, we are going to experience soft, soaking rainfall. Okay, let us look when an occlusion takes place. The warm air is uplifted. So this is the occluded stage. It's an occluded stage. You have very cold front, very cold conditions behind the cold front, chasing after a warm front. Then there's a development of cumulonimbus clouds there with heavy rainfalls. And then you have a warm occluded tier. You can see there's been an undercut of warm air by the cold fronts as the apex. Okay, and then let's see full details of cold and warm front occlusion. Cold front occlusion results when statically more stable air is behind the cold fronts. The cold front undercuts the warm fronts. So warm occlusion occurs when the cold air behind the occluded front is warmer than the air ahead of it. This one you must remember for the exam. The warm occlusion acts in a similar way to a warm front. So the cold air behind the front is less dense, than the even colder air ahead of it. And so it passes over the top of the colder air. So that's what it calls, as well as the warm occlusion stage is about. Let us look at the impact here, mind. So our impact creates in a form of a paragraph. In a paragraph of approximately 8 lines, discuss the impacts that will be caused by a mid-latitude cyclone. So a questionnaire will depend. The examiner will actually set anything around the social, anything around the economic, anything around the environment. So in my presentation, I've included social impact as well as economic impact. So when we environmental impact, let us look at social impacts positive. Let us look at some positive impacts of the social. So they bring rainfall. Mid-latitude cyclone, they bring rainfall, okay, which increases in agricultural production, which will result in more employment. Increase in agricultural production will lead to more food that will be available. There will be employment, which improves quality of lives. Increase in recreational facilities. Uma sekunamanzi amaningi sports lesi sasemanzini possible. So let's look at some negatives. Mid-latitude cyclone, more rains will result in floods, which will lead to damage to properties. Floods decrease accessibility to recreational facilities. Floods could result in loss of lives because people can be washed away and then end up losing their lives. Floods could damage crops, kill livestock, reduce amount of food that will be available. So there will be food insecurity. Floods decrease the production, which results in the decrease in employment opportunities. Let's move on and look at economic impact. Starting a positive, it brings rainfall, which increases agricultural production, which leads to more employment. Increase in agricultural production will result in greater income to the area. Improve aesthetic appeal. Vegetation grows due to rainfall. Snow will attract customers. Oh, sorry, not customers, but tourists. Availability of water supply for secondary as well as tertiary economic sector. Grade 12, ngicela singakhohlwa-ke ukuqualify ama-points ethu. We must, like it or not, we must qualify our points. In order for us to score marks, we have to qualify our points. Because if we don't, if we just, like bring like one-word answers there, and then bazosinika one, it depends, it will depend ukuthi i-marking system abayisebenzisa marking center injani. Sometimes if there is no qualification, they don't accept lama-point forms, lama-points kuphela nje. They only accept a full line, so a full sentence with the qualification. So as be careful, grade 12, whenever we're answering a geographical question, we must qualify it. Okay, let's just go and look at negative impacts and the economic impacts. So floods decrease in agricultural production, which will increase unemployment. And then also floods, will lead to strong winds, will lead to floods or strong winds will damage infrastructure. Floods will restrict accessibility to tourist attractions, which will affect the tourism in the area. So less production will lead to less income in the area. Okay, let us look at a tropical cyclone now that you are done with economic. Remember, I've said at Kaleni we were going to cover a social as well as economic. For the grade 12, you must expect social as well as economic. So we call it socio-economic impact. So nje ungathi damage to infrastructure, ayangena lapha loss of life, damage to properties, insurance companies will pay more as a result of damage to properties and cars. So nje kumele ukuhlanganise ndawonye. Okay, bese kuba environmental impact. Environmental impact, you need to mention everything and anything that has to do noma eyadala uNkulunkulu. So we're looking at the removal of vegetation. We're looking at soil erosion as a result of storm surge. We're looking at the river being polluted. So all those falls under environment. Now, let us focus on the tropical cyclones. So here we are going to be looking at some general characteristics. We'll be looking at the areas of formation and associated terms in different parts of the world, associated weather patterns. We'll be looking at the cross-section through a tropical cyclone. We'll be looking at some impacts on human activities, which includes social as well as economic, as well as we'll be looking at some environmental impacts, which are the impacts of weather system or weather, which is associated with tropical cyclone. We'll be looking at some precautionary measures, what do you need to do so a tropical cyclone is approaching, as well as in management strategies to manage the effects of the tropical cyclone. But before we move on with the tropical cyclone, we must remember what is named alphabetically, but I'm going to discuss that at a later stage as I go through a presentation yami. And then also, kunama precautionary measures that may come in a form of a paragraph, as well as management strategies on what to do uma sekufika isidingo sadlula. Nayo it may come in a form of a paragraph. Okay, let's just look now at a tropical cyclone. What exactly is a tropical cyclone? We have other alternatives. We have alternative names. It's sometimes called a hurricane in the North Atlantic and typhoon in the North Pacific. Tropical cyclones develop at the ITCZ between but outside 5 degrees north and south. Okay, they do not okay between 0 and 5 degrees. Good people. The reason why they do not okay between 0 in 5 degrees is because there's no Coriolis force there. Okay, so the Coriolis force there is absent at the equator, so that is why there's no tropical cyclone. So we need Coriolis force to take place. We need Coriolis force to be there in order for a tropical cyclone to develop. So Coriolis force causes deflection of winds and allows for creation of a cyclonic vortex. So Coriolis force will cause the winds to spiral towards the low pressure. And then this intensifies the low pressure to such an extent that a clear funnel called an eye of the tropical cyclone to develop. And then it is an intense low pressure storm which causes a loss of winds and flood damage. Tropical cyclones only form under very specific conditions discussed later during this presentation. Okay. And then again, Sakona with tropical cyclone, they are named alphabetically. So it's very important, grade 12, for exam yakho, you must know with some tropical cyclones, they are named alphabetically in season they occur. So you may have Uena, you may have Ubeti, you may have Cecilia, you may have Udeneo, you may have Elizabeth. So if we examine Elizabeth, Elizabeth, the tropical cyclone, yes, and then we should say yes 5. But Mabeti, how many tropical cyclones have occurred before tropical cyclone Elizabeth? And then we will say Mangagi, 4. So I say be careful. Okay, main source of energy is latent heat resulting from cooling and condensation of rising air. Remember, grade 12 tropical cyclones occur in the tropical regions over warm ocean water. The system moves from east to west where it dissipates. It originates in summer and autumn, mostly late summer and early autumn, with the temperature, ocean temperature, grade 12, of at least 26.5 degrees. And then also, the system, which is a tropical cyclone, it doesn't need any friction. So, because if it does come across with the friction, the tropical cyclone will actually dissipate. Okay, let's just look now in terms of where exactly Ama cyclones takes place or develop. You can see with this is North America there, and then we have hurricanes taking place. We have Asia there, tropical cyclones, typhoons there next to Asia as well. But around here in Australia, we have willies, even though not include Galana, Southern Hemisphere, South Africa, we have tropical cyclones developing. Okay, now let's just look at some conditions necessary for the formation of a tropical cyclone. You need large sea surface with temperature higher than 26.5 degrees Celsius to be present. You need the presence of Coriolis force enough to create a cyclonic vortex. Remember, the Coriolis force it deflects the winds either to the left or to the right, depending on the hemisphere. You need small variation in the vertical wind speed, a pre-existing weak low pressure area or low level cyclonic circulation, upper divergence A or upper divergence above the sea level system. That's what you need. These are the conditions that are necessary for the development of a tropical cyclone. Kunama stages of a tropical cyclone. Using our palanga, but this is an initial stage or it's a formation stage. And you can notice with some hectopascals, they are way above 1,000. So if you see such a thing with synoptic weather map, you must know with the tropical cyclone we matured stage, so it's starting to develop. And then if you look carefully, with immature stage, you can see with your millibars or your isobars, your hectopascals, should I say, they are starting now to drop below 1,000. So even the hurricane and the wind speed is starting to reach the hurricane winds right here in this stage. And then what will tell you, Emanju, with what stage is this? This will actually tell you everything, as well as the hectopascals. So this is a matured stage, grade 12. And you can see the spiral movement of the wind. you can see what's in the center, isobars are close together, as well as you can see if you read the hectopascals, millibars, they have now reached, they've gone beyond or below, they've dropped below 1000 hectopascals. And then with degenerating stage, you can see your hectopascals are now above 1000 and your isobars are starting to, to move further apart. So as ayaqala lento seqala ukuba gentle no longer steep. So ayaqala nje, they're pulling further apart. So each one of these stages, grade 12, are important, but the most important one is the matured stage, because there are lots and lots of questions that are derived from the stage. And then this would left ule area le. This is called a it's a dangerous circular. So this is an active, basically it's an active quadrant. So this is an active quadrant. La we have strong winds as well as we have heavy rainfalls. Okay, let us look at the formative stage in details. In the formative stage, the cyclone has very strong strong updrafts, as well as the low pressure starting to intensify. The cyclone is not very large yet in this stage, and there is no clear eye. So the wind starts spiraling. Pressure generally is still above 1000 hectopascals or millibars. Immature stage. Within this stage, there's very strong updrafts of air which increases as temperature increases due to a release of latent heat. Ice starts to develop. So ice starting to develop around or in between isobars. Pressure in the center drops below 1000 millibars. Matured stage, which is the most important stage geography grade 12. Pressure gradient. The pressure gradient is very strong, and wind speeds reach hurricane strength. The calm, clear eye is well developed, and the air pressure is well below 1000 millibars. So the forward left hand quadrant is the most destructive, as the intense winds in the cyclone combines with the force of the entire cyclone. Remember, it's a gusty winds corner, as well as heavy rainfall with active quadrant. And then the cyclone can cover distance of more than 300 kilometers from the eye. So the cyclone moves in a southwesterly direction from the equator. So the low pressure and the fast wind over the ocean masses is called a storm surge. The storm surge is whereby amagagas emakhulu yabo leyo nto engena into the land, which leads to further flooding of the coastal areas that hits by the cyclone. Okay, it dissipating stage ila ephela khona icyclone yakho, tropical cyclone. Another name for it dissipating is a degenerating stage. So it's a dying stage basically. So what happens within this stage? When the tropical cyclone moves over land, the wind is slowed down by friction, and there is less evaporation, less humidity to cause unstable air condition. Remember, the tropical cyclone, in order for it to occur, it needs a smooth surface, it needs an ocean temperature of more than 26.5 degrees phezulu, latent heat ideal. Okay, the cyclone also moves into cooler subtropical areas, and the air pressure increases. So weather clears up, pressure increases. Okay, let's just look at the cross section of a tropical cyclone. We are going to be showing only the matured stage. So if you look here, there is an updraft movement of clouds. These clouds can cover up to even 10 kilometers. This is the eye wall. The eye wall yakula. Within here, in between, there is an eye. Remember, phezulu we have a high pressure, la ezansi we have a low pressure. So we examine, they may even ask you, what is the movement? Just give us the movement of air in the eye, and then you will show it subsiding. Then they may even ask you, what is the reason for the subsidence? of this air within the eye, and then you will tell them wind or air moves from high pressure to a low pressure, and then low pressure, it sucks in the air. So it sucks in the air that is above it. So those are your reasons. Okay, and then let's just look at the eye wall, and eye wall, with what is happening there. It's located on both sides of the eye. Okay, it's associated with rising and cooling air of cooling air, resulting in cumulonimbus clouds of great vertical extension. They can be as high as 15 kilometers. Its experience is very heavy rainfall. Heavy rainfall in Linyigama, it's torrential rainfall, and highest wind speed as well. So that is what is happening within the island. Kodwa phakathi la kwi-sensor-ke la, these are the conditions that we have. The eye, it has a subsiding air, umoya uyehla. As air subsides, it warms up, resulting in no clouds formation. Typical conditions are calm conditions, clear skies, no rainfall, and high humidity. It's approximately, remember, the eye can cover up to approximately 25 kilometers in diameter. So ungayitshela ukuthi istorm sesidlulile, yabo, if isifikile kuleyo ndawo, kanti asikakafiki, wena nje usahleli phakathi kwilento kwi-eye, you're still within the eye. The storm is still continuing to actually move. Okay, and then bese ukuthi ngalana-ke we have the rain bands. As we move further away or away from the eye wall, we find the rain bands that can be more than, or that can cover around about 300 kilometers. Okay, now grade 12 nanka social impacts. Okay, acishe fane nawe mid-latitude cyclone. So results in floods. Okay, hurricane force winds, damage to properties, people left homeless. Floods decrease accessibility to recreational facilities. Floods could result in loss of lives. Floods could actually damage crops and kill livestock, which will reduce the amount of food available. Floods decrease in production, okay, which will lead to a decrease in employment opportunities. Okay, economic impacts. Floods will decrease agricultural production, which will lead to a decrease, so an increase in employment. Floods, hurricane force winds damage infrastructure. Floods restricts accessibility to tourist attraction, which will affect tourism in the area. Less production will lead to less income into the area, reduced number of tourists into the area. Government spends significant amount of money on repairing infrastructure and supporting people. So grade 12, ilokho nje ngiphathele khona for now, on a mid-latitude cyclone as well as a tropical cyclone. So please study hard, do those paragraph questions, make sure that you support them, you support every answer, make sure all your answers are qualified. I thank you.